All right, so I'm going to do a couple of these to help you with number 21. The first thing I really recommend is to make a note card with the laws of exponents, which I've written to the right. I'm not using my iPad pen, so it doesn't look as nice, and I actually messed up my Q over P. But you're going to use this so much, so if you commit these to memory right away, it's going to help you. I'm going to do number 24 first, just to give you an idea of how to handle the second term in number 21. The first step is to go to the laws of exponents. Wherever you have a root, you're going to use number 4 to change this to a fractional power. So you probably remember using this in pre-calculus or even earlier grades, but it's actually super important here in calculus. The next step is to split this back up. So breaking up is easy to do, unless you're in love. Your backward common denominators is what we call it in my other classes. So x squared is my common denominator. I'm usually supposed to combine these to the green, but now I'm going to split them back up. So you're going to break it up. Next, I'm going to use this rule over here. X to the m divided by x to the n is x to the m minus n. So I have an m here. In this case, it's 1/2. An m down here, it's 2. An m up here, it's 1. And an m down here, it's n down here, it's 2. And then you just plug it into this formula number 5 in the laws of exponents. And then I do the math with I'm not very good with common denominators and fractions. I'll make mistakes. Do them on the calculator, or if you're like me, get a common denominator by thinking of 2 as 4/2, and then 1/2 minus 4/2 is minus 3. 3/2, 1 minus 2 is -1. So many opportunities to make minus sign errors. Finally, you did so much algebra, you think that, well, I'm done. You're not. You still were supposed to find the derivative. And now I'm going to apply the power rule, which says that I take the power down to the front, knock the power down by 1. I take the power down to the front, I knock the power down by 1. And so I'm very careful here, -1, -2. And then notice here I get the common denominators one more time, and that turns it to -5/2. So this is a bookkeeping problem. So it's very important to remember to be careful. So what are you going to do? You're going to change this term here on your problem to a fractional power, P over Q. And after you change Q over P, after you change that to a fractional power, then you're going to bring it upstairs. One more. I'm going to do the last one, which is the exponential. It's one of the big 5. The big 5, I'm going to come up with the big 5 in a second, but it's like the Pac-10, except it's the big 5 of calculus. E to the x prime is e to the x. Jama wants to get my attention this morning. All right, so here first, e to the x plus 1 in this problem is really e to the x times e to the 1. E's don't bother me, it's just a number. And if you look over here, where am I getting that from? It's x to the m plus n is x to the m times x to the n. So this just splits off. I'm just using that rule backwards. And this is just a number. So I'm going to pull that. We typically pull this to the front. It's like a 2. It just goes to the front. And then I take its derivative. Applying the big 5, I get the derivative of e to the x is e to the x. There's a constant out in front. The derivative of 1, it's a constant, is 0. So it's e times e to the x. You're going to do something similar. My e is your 3. So it makes no difference to me if one is easier than the other. It's just 3 is a number and e is a number. So you would do the same thing to this first term that I did to this, except you don't have this front end work to do first.